For this IP, this is the subnet mask, which means 10 is the network. The host portion is 001. That's the meaning of subnet mask. Subnet mask. Subnet mask will tell you how many bits in the above address is network. Just 8 bit out of 32 is network. If that is the case, this is the last IP. So last IP I'm giving as address of router, which we call it as gateway, default gateway. Router's address is what called as default gateway. So these are the 4 components that you will be assigning. One, IP address, another one, subnet mask, another one, gateway. The 4th component is DNS server address. So that when you try typing some domain name, the IP address to reach the domain name can be learned from the DNS server. So DNS server is in the internet. It's in the public domain where it will have all the domain names and the IP address. Even those who registered the web page, the domain name yesterday, we can reach them because the address to reach them is there in the domain name. Sorry, DNS. For example, someone has launched a web page called universalfriends.com. So if you want to open their page, it is possible. You don't need to know the IP address. You just type www.universalfriend.com. Your PC will go to the DNS server. Means you need to provide the IP address of the DNS server so that your PC can go to the DNS server and ask what is the IP for reaching universalfriend.com webpage domain. Universal Friend is a domain. It's a web page. And DNS will provide an IP address to this computer. And this computer will now use the IP address to reach the web server to get the web page. This is how DNS is used to resolve the domain name into IP address. See, our computer cannot maintain the IP address for all domains. Not possible. What if the IP address changes for a domain? Then you need to change. Not only you, the entire world need to change. And those website that is launched yesterday, how will you know? Not possible. Maybe in the television or in YouTube, you will see some domain name. But they don't advertise any IP address. So we put the domain name and then we see the page like magic. It's all because of DNS server. So when you put the domain name, the control goes to the DNS server asking for the IP address of the domain name. Okay, that's the job of DNS. DNS resolves domain name into IP address. Our computer needs to know the location of DNS server. This is the universal DNS server IP address. Everyone knows this one. 8888 is the universal DNS address. 8.8.8.8. It's a known one actually. 8888 is a known one. well-known DNS address. Here you go. You say Google's primary DNS server is 8.8.8.8. Don't think they maintain only the Google's domain. No, they maintain all domain name and their IP address. And the secondary is same, starting with 88 but .44. Likewise, you have many DNS server, but these two are famous. These two are famous. Right, going back to our PC, ipconfig. Alright, so we don't need domain names. I did not give. Did I give? Did I give? It is okay if you give also. We are not going to use it anyhow. Let me remove why unnecessarily we keep this here. So this is what IP address I want. What is it? Not needed. Why you don't have any exercise to reach some web server? Not necessary. It's not mandatory. But if your computer wants to go online, definitely you need it. In this lab, we don't have any such exercises, so not needed. But it is not mandatory to put. If you put, you will get internet in the real world. I'm talking. If you put, you will get internet service. If you don't have IP address filled in that column, your computer cannot provide any web page. Even though you have internet, you will not be able to get any web page if the field, the DNS field is blank. If you want to reach any web page, you need to type IP address instead of yahoo.com. You need to type the IP address in the address bar. Only then you can go. If you put IP address, you don't need DNS. It can go straight away. For example, http:// Okay, even if I don't say it's going to be HTTP, what happened? So then address is wrong. Connection. Okay, so that's not the address. There is another way to find the IP address. It's very simple. Let me do it. Ping www.yahoo.com. Actually, this time it's going to use DNS to resolve. I already have given IP address to reach DNS. It's going to use the IP address. Go ask the IP address of of Yahoo, and you see this is the address that DNS has given: 200.165.170.107.50. Let's do this now. Look at this. It opens Yahoo. Yahoo will be right back. Thanks for your patience. Our engineers are working. I don't know. So anyway, yeah. Right now, to get this Google page, I just typed the IP address of Google. and it got this page for me. So what we understand is if you don't have DNS configured, you have to put IP address of the domains, which is not possible for us to remember because the address changes often. Today you may be using this address, tomorrow it's not guaranteed to reach Google this one. They will have different server. So DNS is required, but for us we don't have any web page to resolve, so no need. Alright, on this computer I'm going to give 10.0.0.2/8, and in this computer I'm going to give 20.0.0.1/8, 20.0.0.2/8. Okay, I want 2 here. Okay, just change to 2. Now, a mistake here, nothing is given. Here only 10.0.0.1, 10.0.0.1, 255.255.254. This will be the IP address configured on the router. That is what gateway is. IP address of the router is the gateway. Okay, next. For our reference, I'm writing, you no need to write like this. Sorry, 255. This is the last IP in that network. We'll configure router later. Let's go to this right hand side. This is going to be 20.255.255.254. The last IP address of this network. Finish this PC. 20.0.0.1, 20.255.255.254. Now on the second computer, twenty dot zero zero two, 20.255.4. All right. So the PCs are ready to communicate. Let's put the IP addresses on the routers. Before that, let me do some planning here. Between these two routers, I would like to have 30 network, 30.0.0.1/8 here, 30.0.0.2 here, and likewise here 40.0.0.1, 40.0.0.2. Right now, this we need to put it in these interfaces. See the name of the interfaces. You have 00, for example, on router 1. F00, I need to put this IP address. F01, I need to put this IP address. Using this 40, these two can talk. Using the 30, these two can talk. Using this 10, these three can talk. Using the 20, these three can talk. We call this as LAN. We call this as a LAN. This is another LAN. Okay. Yes. Let's begin the configuring IP address. We always say no here because we do not want to use any dialog to configure. We want to go straight away to the configuration mode. I want to change the name of the router. See, for your reference, I double click here. I want to change it as router A, RA. This one is RB. So this is like taking a paper and writing it out and pasting on the router. In the real world, we paste it on the router, the names. Now you need to also put the name here inside, the same name. Enable config T, host name, no space in between host and the name. It's one single name, RA. And then we need to go under interface, F00. Bring the interface up by typing no shutdown. So as soon as I say no shutdown, it has turned green here, the small dot. IP space address 10.255.255.254, 255 mask 000. Assigning IP address is over on F00. Now let us assign IP address on F01. IP space address 30.0.0.1 0. See, even though I have said no shutdown, it has not turned green. The reason is, though interfaces come up, when it sends some hello packets or like keep alive packets, the other guy is not responding because the other router is down. The other router's interface is down. Other router may be up, but the interface is down. For security reason, all the routers interfaces will be in a shutdown state. You need to say no shutdown to bring it up. Whereas the switches, the ports are not shut down by default. As soon as you plug, you can play. All right, so router A is over. Let's move to router B. Router B, host name RB. You see, as soon as I go inside the interface F00 and say no shutdown, that will turn green because our A is also up already. Now I'm bringing this one up. See, turns green. Both sides it turns green because it is not only up, it can also send and receive the keep alives, the line protocols. For the protocols to get response, both sides it should be up, isn't it? Yeah. Okay, so we move on to no. We need to assign IP address. The IP address here will be 30002 as per the plan and the mask. Exit. There is another interface F01. Bring it up and put the IP address 40001. Yep. And I'm going to assign IP address. Sorry, assign the IP address is assigned. No shutdown is given, but still it is down because the line protocol is not up. For what reason? Because the RC F01 is still down. Yeah. So let's move on to RC. Host name RC, interface F0/1, no shed, IP space address 40002. Now it is up on either side. We have assigned IP address on this. Another interface we have is F00. So I just typed F means fast internet. I press the tab button, it will fill the remaining character. It's called autofilling. These things we covered a bit earlier in the basic classes. Finish this last interface. IP space address 20.255.255.254. And the mask is 255.255.0. Bring the interface up, it turns green. You see this side it has turned green, and slowly switch will also turn green when the negotiation happens. Okay, so what is next? We're going to learn two type of error messages which will be very useful for troubleshooting. From the Windows side, from the computer side, not only Windows, it may be Linux, anything, Apple, iOS or whatever. You will have always two type of error, network errors. There is no much error codes. Only two you will see. One is request timed out. The other one is destination host unreachable. You see, when I ping the gateway 10, before I ping, I want to show you the ARP table. ARP-A. ARP table is empty. Now I'm going to ping the gateway. Ping, what is the gateway's address? This one. Gateway, who is the gateway? The router. Now I'm going to ping the router. See, because the router is also in same network. 10, 255, 255, 254, I can reach. But to reach, first I need the MAC address of the gateway. So ARP will resolve the MAC address, and it is given actually. It is resolved very fast. So there is no packet loss. If you now see ARP-A, look at this. You can see the MAC address. Earlier, It was empty. So ARP has resolved the MAC address, and using the MAC address, the ICMP. When you ping, what protocol comes in the picture? ICMP. ICMP comes in the picture. And you see the TTL is 255. Yes, it's a reply coming from router. Routers will put TTL of 255, and it is coming from the immediate hop, first hop. That's why it is 255. There is no router in the middle. If you have one router in the middle, you would have got 254. There is no router in the middle. All right. What is next? You get a reply when you ping, and this is the MAC address of the router. Router's F00 interface. If you want to see, I can show you. So I want you to remember this number 97 C501. Okay, 97 C501. Let's go here. This interface, MAC address is what you saw there. How to see the MAC address on the router? Show interface F00. If you go top, you will find in the bracket, look at this, 97 C501. It's exactly the same MAC address, 97 C501. So what does ARP do? It resolves the IP address into MAC address. All right, so this PC can very well ping the gateway. Let's ping from here. ARP-A, this also do not know. I'm going to ping first 10001, which is another PC in the same LAN. Now, if you see, you will see the MAC address of 10001, the other PC, but it did not use the gateway. You know why? Because I'm pinging the same network, another device. But if I try pinging 20001, it will first resolve the MAC address of the gateway, and you will see that in the ARP table. And the error message you're getting is destination host unreachable. I'll come to this one, but I want to show you the ARP. Look at this. I did not ping gateway, but it has learned the MAC address of the gateway. That what does it proves? That proves that when I ping 20 different network, it was trying to go to the gateway first, and it went to the gateway by using the MAC address provided by the ARP, and the gateway is telling you. See, you did not ping this address, but who is replying you? You did not ping gateway. Gateway is replying, which means gateway got the request. Gateway says, the destination that you are trying, I really don't know. That's the meaning. It shows that router do not know what to do, where to go. So router is telling you, I don't have a route. If you want, you give route, then I can ping. This is one of the message, error message. Destination host unreachable. The other one is request timed out. When will you get the request timed out? When your gateway knows the address, and the gateway knows, when your router knows the location of 20001, and when your gateway forwards it, for example, router A knows the route, assume. Currently, router A don't know the route. Router A knows only about 30 and 10. Let me show you that. Show IP route. Router A knows only 30 and 10. Dynamically learned because you put the IP address. As soon as you put the IP address, this comes. But you don't know about 20. What you did, you write a default route. This is edge router, no? We can write IP route. any network, any subnet mask. This is what called as default route, and you say any network, any subnet mask. If router A don't know, it needs to go to 30.0.0.2, which is the next router. Now if I ping, this time also the packet will go to the gateway, but gateway will forward the packet. Not this PC, we were testing from this PC. This time when I ping the same destination, it will not say destination host unreachable. Why? Because gateway knows the destination. This computer's gateway knows the destination. How? We gave a default route. In the default route, we have said any network you don't know, you send it to this guy, the next router. You see, routing table. S star. So when you ping now, you will not get destination host unreachable, rather request timed out. Why request timed out? You see, A has sent, but B is not forwarding it. Why? Because B don't know about 20. So A is waiting for B to provide the response, but B is not going to provide because B did not even forward the request. The ICMP request, the echo request, you see. Show IP route. This don't know about the route to reach 20. Say show IP packet. Sorry, not show. Debug IP packet. Debug is the command that which you should not use in the production because it will take a lot of buffer. Debug IP packet. Now I'm going to ping and show you from here again. RA will be forwarding the packet to B. You see, a packet is coming from 10.0.0.2. It wants to go to 20.0.0.1. But router B says, sorry, for me it is unroutable. It says, I cannot do anything with this packet because I don't have root. But the problem is B cannot notify this to A. A simply waits. See, there is no route to 20. So A simply waits, and then this computer also waits. Who said this is the one who sent the echo request. After waiting, the session layer said, hey, you waited enough. If you simply keep on waiting, then how others will use the network? Tell me. So better you say request timed out. Let the user know that something is wrong. Don't simply keep on waiting. See, that's the job of session layer. It will not keep the session open when there is no response forever. So after like 10 seconds, you see, 1, 2, 3, 4, 5, 6, 7. Actually 10 seconds. I'm counting slow. It says request timed out. Meaning that's the maximum time I can wait for someone to respond. So I'm saying I didn't get the response. It is timed out. So when will you get the request timed out? If the destination is not responding back. It may not be the destination. It may be some routers in the path do not know the route, like our scenario. Let's say I give a static route here. Undebug all. You all means undebug all. I'm stopping all those debug. Now show IP route. This don't know the route. I'm going to give a route IP route 20 network. If this is the mask, send it to router C. You see, I have given a route now. Router B will now forward it to router C. You see, I'll put the debug again, debug IP packet. Now if I ping, the packet will definitely go via B to C. And I'll also, okay, well, let's first see this. You see, but this time also I'll get request timed out. I'll tell you the reason why. You see, request timed out. But B is forwarding the packet, you see. B is forwarding to gateway 40002. Who is 40002? Router C. What about router C? Debug IP packet. Again, I'm telling you, don't use this debug command in the production because it takes buffer more. Now I'm going to ping again. Even router C will be forwarding the packet, you see. It is forwarding the packet to 20001, which is this computer. Then why I'm getting request timed out? The reason is, you will see the response coming from 20001 wants to go to 10002. Correct? No? From there only we are pinging. The response want to go to 10002, but C do not know where is 10. Correct? No? See, show IP route. How C knows about 10? See, a request was coming from 10002. It went to the PC like this because you wrote default route here, you wrote static route here. Here you no need to write any route, it is directly connected. You see on B we wrote static route, show IP route. We wrote static route. So the packet went here, it even went to 20001. But when 20001 reply, it will reply to whom? It will reply to 10 from where the request came. But the poor RC don't know about 10. That is why the reply didn't reach back request terminal. So, see, destination host unreachable is easy to fix because your gateway don't know the path. But if request timeout comes, it may not be your gateway, it may be someone in the middle like RC, RB, and RC problem. You know. So this is under your control. This is your edge, your company. If you get destination host unreachable, which means your gateway, your router, your edge router don't know the route, you can go put the route and you will be fixing the problem. But if the request timeout comes, there are many reasons. One of the reason is this to know the route. The other reason is this remote edge router, they don't have a proper route to reach us. Now, if I put the default route here, send it to 40001. Now, if you ping, the packet will come down here, but RB do not know the route to 10. Let me show you that. Debug IP packet. Now if I ping from here, even now I'll get request timed out because when C replies back, see from 20001 the reply is coming to, it's a reply packet, but unfortunately unroutable. RB says sorry, I cannot route it, I don't know the path. So on RB we need to add another route, IP route 10000. Send it to 30001. Now your ping will be successful, you see now. So the route should be to and fro. Two errors we learned: request timed out, destination host unreachable. Two common errors. To troubleshoot, destination timeout, request timeout, you need to check every device in the path, including the destination. But destination host unreachable, the problem is on your side. Destination host unreachable. Say for example, I don't have a gateway configured. I don't have a gateway. Now I'm pinging this. Even now I'm going to get request timed out. Because they don't know how to resolve. Here the packet did not go out. See, request timed out sometimes can be our problem. What problem? Gateway problem. Now when your gateway is correct, if you get request timed out, then it is not your problem. It's a problem with destination or the middle routers. And when you get destination host unreachable, I'm going to remove the default route that I gave. I gave no default route, show IP route. I gave this default route. If I remove this, I'll get destination host unreachable. This is how we write. We remove, go same place where you put the command and type no IP. No is will delete it. No IP route and network. Any subnet mask. Send it to 30.0.0.2. I cancelled it. Now check the routing table. No route. Even though the other routers, everyone in the internet knows the path, your own router don't know the path. Now you ping destination host unreachable. So if the destination host unreachable is seen, go and check your gateway, your router. Go and check your router. There is no root, support the root. I'll remove this no. After you put the root, you got the root, default route. Now you ping, you have fixed the problem. Yes. You can also ping from here. I'm picking the other computer. So it will take some time because the MAC addresses are involved, you see. Why request time not the ARP reply? Now, for 20.2 also you will see the same gateway only. You will not see the MAC address of 20.2. When you ping 20.2, it is forwarding to the gateway. So don't expect the MAC address and the IP address 20.0.0.2. Right. So in our today's class, we have learned how to write default route and static route. In RB, you cannot write a default route. You should write static route because unknown destinations are in two different directions. 10 network is in 30.0.0.1 gateway and 20 network is in 40.0.0.2 gateway. Because they are in two different directions, you cannot write default route. See, we have two different gateway for two different destinations. You need to write only static route. Whereas on the edge routers, stub routers like RA and RC, all the unknown destinations are in one direction. For our router A, reaching 40 or 20, you need to go to 30.0.0.2. That's why we wrote default route Likewise, for RC, to reach all unknown destinations, you need to go to B. Show IP route. That's why we have given this. All right. So that's